Okay, friends, so we have successfully awarded the winners of the Cereal Box Challenge. So if you wanted to hear how I would have walked through this problem, let me show you. Alrighty, so you remember the problem, simple problem, and it was about simple to present, difficult to solve. So here's the situation. Basically what we have is we have a sheet of paper, and what we're trying to do is maximize the volume that could fit inside this box created by removing the squares from each corner. Each of these squares would be the same size, but obviously the smaller the square, if the square is too small, you couldn't fit any cereal in that. And if the square was too big, you wouldn't even have a box. So that's kind of the concept. So what I'm going to do is help you get started here. I've noticed that in general, a lot of us are still learning how to draw good pictures. So I'm going to make my best attempt with this mouse. So here we go. So the first thing I'm going to do is draw that piece of paper. Why? Okay. Oh, I see. I see. Okay, so let's see how this goes. So the first thing I'm going to do is I'm going to label this 21.6, and that goes all the way to the edge. Okay, that's going to be 26.6, and that goes all the way to the edge. Now what I'm going to do is I'm going to add the dotted lines, because remember, is if we fold those up right there, that's what the height is going to be. So what I'm going to do is I'm going to very carefully label that little guy H, and that little guy H, and that little guy H. Those are all little H's, and I might just start making those little congruent symbols there, so I know that it's H. So then when I label this guy here is going to be 26.6 minus 2H, and this guy here is going to be 21.6 minus 2H. Okay, now I've gotten a bit ahead of myself, and I'm gonna pause just for a second. I'm gonna make my screen here a bit bigger. Hopefully that doesn't impact you at all. So what I probably also should have done should have been to let's see, it's create a formula here, and we know that the formula for maximum volume is going to be length times width times height. Okay, so I'm going to need to create that. So once again, remember, this was 26.6, this was 21.6, and that goes to the edge there. And each of these guys, they're equal. All of those are the same. We know that, and that's a distance of h. So when I go down here to do the corresponding 3D image or 3D representation, make sure you have it. I know a number of people weren't relating the 2D and the 1D, and that can get you in a bit of trouble in terms of your clear communication of what's happening here, okay? Alrighty, and then we can call this distance here h. So if I were to fill this in, we're going to have volume equals length, which we could call 26.6 minus 2h, big fat bracket, 21.6 minus 2x. That's getting kind of messy, but I hope you can follow along, and that's going to be h. Okay, now what was really classic is if we were just trying to find the solution, the quickest way to make sense of this is just to get over onto Desmos. And so I'm going to type that into Desmos. So let's do it. We're going to go 26.6 minus 2x bracket, and then it was 21.6 minus 2x, and then we're going to go x. Okay, and you can see right now that the scale is, it's hard to see that. So I'm going to try to get a sense of this by making it a bit shorter. So I'm going to change the scale from a maximum of 7 to, I'm going to make it, oh, there it is. I don't know if you saw that, but it came in quickly. So that's what this curve looks like. And if I plot right there, I can see that h equals 3.9. So if I came back to my equation, I know that h equals 3.9, and I can figure out what the maximum volume was. Now that would be accurate to 3 decimals. I know that many of you went on and found that by other means, and that's fantastic that you did that. And for what it's worth, I am not going to complete this problem. I'm going to tell you what the next steps are if you are interested. Okay, so my move, if I was just interested in, reasonable accuracy, I would have just used Desmos. Algebraically, what you want to do here is you're going to expand all this out, expand it out, simplify. So I'll write this in, let's go in yellow. I don't use yellow very much. So we're going to expand. So I trust that you know how to expand that. I am not going to go over how to expand a trinomial here. Or that's not even a trinomial, three terms being multiplied. Okay, we're going to expand. We're going to set v prime equal to 0. Or sorry, we're going to find the derivative. So find v prime. Then we're going to set v prime equal to 0, and then we're going to solve for h there. And what does h equal? Okay, then when you're going to find h, once you find h, of course, you can put it back in here to figure out what the volume is, and you can go from there. So if you were looking for details to the very end, you're not going to find it here. I will say that when you set this sucker equal to 0 and you try to find h, you're probably going to want to use you're going to need to use the quadratic formula. You don't need to memorize that. In the challenge, I would have just Googled, quadratic formula calculator. So that's what I would have done. But obviously you're not going to be able to use that on an assessment, so you do need to be able to use it. But all you do is you just simply put the values in for A, B, and C into the calculator. So let's suppose it was 5, 6, and 29. I don't know if that's going to lead to anything. Hopefully it does. And it tells us exactly what the values are. So you could have done that. And that's from calculator soup. But anyhow, we'll leave it at that. Once again, you need to draw your picture, label it well, start with sort of words or sort of a general goal of where you're going. Then we're going to translate that into equation. We're going to expand it all out. We're going to take the derivative, set it equal to 0, solve for h. And there you go. So that was short, it was sweet, and I hope it helped. Good luck and chat soon.